Hi friends, already we have discussed banking of the road and then safety speed. Let us discuss few problems related to this one. It is problem 5.10. A cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius 3 meter without reducing the speed. The coefficient of static friction between the tire and the road is 0.1. Will the cyclist slip while taking the turn? It's a problem number 5.8. There is a cyclist. We all experience it. And then it is a problem. Solve the problem. He is traveling with velocity 18 km per hour. We can convert it into 18 into 5 by 80 meter per second. It becomes 5 meter per second. This is the velocity in meter per second. Here mu s is given 0.1. Radius is given 3 meter. We know safety speed Vmax bracket square is equal to mu s r g. G we can take it as a take. So here Vmax is equal. So squaring both the sides, Vmax square is equal to mu s r g. Mu s is 0.1 into 3 into 9.8 suppose. This 9.8, if you check it, it is coming as 3 8s are 24, 27 and 2, that is 29, 2 decimals, meter square, second square. Square of safety speed is 2.94. Here the speed of the cyclist is V is equal to 5. V square is equal to 25 meter square minus 2. You can see that very clearly. V square is greater than Vmax square. To take a turn with this speed, it is not safe. Therefore, cyclist will sleep. Cyclist will sleep because he is exceeding the limit. He is exceeding the maximum limit. Now there is 5.11, but in this 5.11, root we have to calculate, and then when we learn this log, then we can find out this root. Now I am moving to the next topic. 5.11 I am not discussing it here. I am going to the next topic, that is the solving problems of mechanics. See there, how to solve the problems of mechanics, and for this one, I take a problem directly. It is 5.12. 5.12, see figure. A wooden block of mass 2 kg rests on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on top of the block, the floor yields steadily and the block and the cylinder together go down with an acceleration of 0.1 meter second square. What is the action of the block on the floor A before and after the floor yields? Take G is equal to 10 meter per second square. Identify action-reaction pair in the problem. First case. It is a very simple case. It is a block there. 5.12 solved. Solved problem. There is one block kept here. Now, how much is the mass of the block? It's given there. A block of 2 kg. It's a 2 kg. Mass of this one is M is equal to 2 2 kg. So W is equal to mg, which is equal to 2 into 10, which is 20 Newton. Floor, it is kept on floor. It does not yield, it is a steady. The block is steady. It is at rest. It does not yield the floor. What does it mean? It simply indicates vertical and horizontal forces are 0. It means that reaction force is R is equal to W, which is equal to 20 Newton, but it's in upward direction. There is 20 Newton reaction force, but it is in upward direction. Now situation second. There is a block. Weight of this block is 2 kg. And then on top of that, there is the cylinder is kept, and that cylinder, it is having mass 25 kg. That is M of cylinder is 25 kg. So together, if you see this one, it is 25 plus 2 kg. Therefore, W is equal to 27 into 10, which is 270 Newton. It's in downward direction. We want to find out the reaction R prime. But what is happening now? This complete system is coming in downward direction with acceleration 0.1 meter per second. It is accelerating. What does it mean? This downward force is more as compared to this reaction force. Otherwise, if they are equal, it will remain at stationary. So here, that is 27.0 minus R prime is equal to M into T. Difference, it's in downward. This is greater, therefore it is coming in downward direction. Therefore, 27 minus R prime MA. This one is this, which becomes MA is equal to mass is 27 0.1. So that is becoming 270 minus R prime 2.7. R prime is equal to 270 minus 2.7, which becomes here 0.3 10 7. So normal reaction is equal to 267.3. So situations are different. In one case, it was stationary. In other case, it was moving in downward direction. So here reaction is reduced. And these all laws, Newton's laws, 3 laws we have discussed. These laws are very helpful in solving problems in mechanics. We are using them. While solving problem in mechanics, we follow following steps. First, we consider or we draw schematic diagram of the complete assembly, including link and support of different parts. Second one, we consider suitable part of that system, suitable part of that complete system separately, which is called as system. Just separated part is known as system. Remaining part of that one is known as environment. We draw free body diagram of system. Next one, in this free body diagram, we include all the forces. That is, whatever known, given, and we are sure of. Remaining things we consider as unknown. And fifth part, if necessary, we consider some other part of the assembly as a system. But while considering other part of the system, Newton's third law needs to be employed. It means that if in one assembly A is a system, and in second A is exerting force F on B, and now second time we are considering system as a B, then force on B is minus F. Here action and reaction pairs needs to be followed. These are the steps given. It is given in textbook also. You can read this one. But these steps are very useful in solving problem the way we have solved this problem. This was the last topic from this chapter. Here we completed our 5th chapter. I request all of you to read chapter from textbook again. Watch all these videos wherever you find difficulty in understanding. In combination, make your own notes and then study for understanding the topics, not just because of you want to appear for some exam. If you start working from understanding point of view, it's a very interesting thing. All this one, it's a thought-provoking also. The education is that which compels you to think, and if you start thinking on all these situations which are given in textbook, then you will be able to handle unknown situation. That's all for this topic. Next chapter, work energy, we will start in next week. Thank you.